What is up, you guys? So in this one, we'll be talking about time constraints in your program. So let me get rid of all this and keep the factorial function. So far, we know how to create a thread. Let's say std thread t1, pass it factorial and 6. We also learned mutex to synchronize data access. So the way to create it is by std mutex. And the mutex has also member functions lock and unlock, but they're not recommended to directly utilize them. Instead, we should use a lock guard. Remember? A locker on mu. And if you need more flexibility, you should use a unique lock and mutex onto the locker mu, or call it unique lock. And a unique lock could lock and unlock mutex multiple times, right? You could also transfer the ownership of a mutex from one unique lock to another. We also learned condition variables. Standard condition variable cond, which is used to synchronize the execution order of threads. And then, we also learned about the future and pinky promises. We can create a promise int as such, which is used to send the integer variable, and then I can create a future as such. So std future, also int f is p.getFuture, as f could be used to fetch the variable sent over by p. We also learned about the async function, which is another way to spawn a thread. Now an async function can also return a future as such, async factorial, and pass it 6. Keep in mind that async can either spawn a child thread to run the factorial function or run the factorial function in the same thread. And finally, we learned about packaged tasks in the previous lecture. The way to define it is as such. Class template can be parameterized the way the function signature of the task that we are going to create, which in this case is factorial. And later on, the task could be executed the same way you run a function. The task can also return a future, let's say foo2, to fetch the returned value from the task. So these are the threading utilities that the std standard library provides. We can also add a time constraint to some of the utility functions. This is achieved by using the Chrono library. Now, if you're not familiar with this library, we'll be talking about Chrono libraries in future lectures, but for now, let's start with a thread as such. Let's put this thread to sleep for, remember here we use Chrono milliseconds. Let's say this thread sleeps for 5 milliseconds. Now let's define a time point over here. Chrono steady clock time point TP. Let's say it's a sum of 2 time instances. So steady clock, let's say the current instance plus, let's say in microseconds, I'll put 4. Then I can also put the thread to sleep until the time of TP, right? Mutex also has a similar thing. Let's call a ulock over here, ulocker. Try a lock, and this will try to lock the mutex, and if it's unsuccessful, it will immediately return. A ulocker can also try lock for a certain amount of time. So let's say chrono in nanoseconds 500. In this case, if 500 has passed nanoseconds, 1000. In this case, if 1000 nanoseconds have passed and that mutex still cannot be locked, then the function will return. You can also do a ulocker.try lock until a certain time point, TP, let's say. You probably have seen the pattern. The functions that end with _4 takes a duration, so like this and like this. And the functions that end with an underscore until takes a time point as a parameter. And the same thing for a condition variable. We can do a wait for, which takes a duration, chrono, say nanoseconds, 6. You can also wait on a condition until a certain time point. But the difference here is that it also needs to take a unique locker as a first parameter. Also for the future, it has a get function, but also has a wait function. So get, and it also has a wait, which waits for the data to be available. In fact, the get function will internally call the wait function. So if the get function finds that the data is not available, it will wait. And for the wait function, it also has a wait for that takes in a duration, say microseconds, 6, and it also has a wait until a certain time point. So all in all, this shows how the thread libraries can be used with certain time constraints. So this is it for this lecture. If you found it beneficial, please leave a like on the video, subscribe to the channel. If you have any questions whatsoever, kindly leave a comment down in the comment section below, and I'll make sure I'll get to it as soon as possible. Thank you so much, and I'll see you then.